So 4.7 day 3, Law of Cosines. So on day 3 of chapter 4.7, today we're going to be looking at the law of cosines, but first of all, here's your warm-up. So with these 3 questions, sketch a triangle. Remember, if you've only been given one angle, remember where we recommend you draw that angle. You mustn't solve these problems. All you're going to say is there a solution or no solution? And if or is there one solution, 2 solutions, infinite number of solutions? Work that out. So pause your video and try these. So on question number 1, there should have been 1 solution. Question number 2, you'd get no solution at all. And question number 3, you should have got 2 solutions. So let's have a look at these in a little bit more detail. There was this spreadsheet that we looked at yesterday. If you've been given side-side angle, there's 2 scenarios, depending if you're trying, the angle you've been given is obtuse or if the angle you've been given is acute. If you've been given an obtuse triangle, then the side that corresponds to it, the side that's opposite it, must be the longest side in the triangle, because any obtuse angle, there can only be one in a triangle, it must be the largest angle. So if you've been given a side-side angle, all of this only applies if you're given side-side angle. If you're given angle side angle or something like that, it's different combination. This isn't, you can't use this flow chart. It's only for side-side angle. So this is an obtuse. If this corresponding side to the angle is the longer of the 2 sides, you should be able to get 1 solution. Very occasionally, it might be just a bit longer than B and still not quite long enough to reach the base here, but that's quite rare. But definitely, if this side is shorter than this side, there will be no solution. If the angle you've been given is acute and this side that corresponds to the angle that's opposite is longer than that one, life is fine. If A is bigger than B, if the corresponding side is bigger than the other side, you can just work it normally. There will be only 1 solution. You don't have to do anything fancy. If this side is shorter than the other given side, then it's important that you could just go in and start trying to solve, but you're probably going to do work you don't have to do, or you're probably going to miss work that should have been done. If this corresponding side is short, if this angle is acute, check that height. This height, you think of this little right triangle here. In this little right triangle, the sine of this angle is equal to the opposite divided by the hypotenuse. So you can use sine. This height then, if you solve that little equation, would be B times the sine of this angle. If that height is longer than A, then A is too short. A can't even reach the base, okay? So you check the height. If the triangle is tall and this side is too short, the corresponding side is too short, you're going to get no solution. If this is exactly the same length as the height, you're going to get just 1 solution and it'll be a perfect right triangle. You'll get this one. If the height isn't as long as this side is longer than the height, you will get 2 triangles. You'll be able to get one where, let me draw a pencil, where this can come down and reach here, or it could swing down and, oh gosh, there would be more like that and that, wouldn't they? Okay, but these purple lines I've just drawn are longer than that height. There'll be 2. So you're going through this flowchart. So let's go through these questions one by one. If we look at this one, sketch it. Oh, let's just get rid of that thing entirely, do them all at once. So when you sketch it, this is the angle you've been given. Put that down here. So Z would go here. So this is side Z, and that's 105 centimeters. Put the other side on the left, 96. So we have been given side, side, angle. This would be, by the way, this is x, little x. So the vertex x would be over here. And I imagine this is triangle, oh, x, y, z. Y would be the other y vertex would be up here. This is obtuse. This side here is longer than that side there. So on this one, you should get one solution. Now let's have a look at this one. Triangle ABC. This is the angle we've been given. We've been given angle B. So call this vertex B. This is your angle. It's 85 degrees. So side length B would be opposite it, and that's 48. Then the other side you've been given is C. Always put that other side on the left. So this is side length C. It's 56. So this must be vertex C. The other vertex must be vertex A. Okay, now the corresponding side is shorter than this one. We've been given a short, acute, side-side angle, a short, acute donkey. Okay, so it's very important that we work out the height. So to work out the height of this triangle, that height there, again, the sine of this angle is going to equal that height divided by the hypotenuse of this little right triangle. Sine of 85 equals h divided by 56. So height equals 56 times the sine of 85. Plug that in your calculator and you work out it's 55 point, that's nearly 56. Oh, well, a bit less. I don't want to use 56, that's 56. So it's 55.789 centimeters, inches tall. This side's only 48. There's no way you could lean a 48-foot ladder against a 55.7-foot wall and it would touch the ground and the top of the wall. It can't possibly happen. This side is too short. It wouldn't actually be able to reach C. It would finish about there. Okay, that's why there's no solution here. And in this triangle, again, we've been given an acute angle and the side that corresponds to it R. This side is short compared to that one. So we're going to need to work out the height. First of all, let's label this up. So I'm going to put the angle I've been given here. That's 29. So this is going to be vertex R. This would be side length R, so it's 23. The other side, P, goes here, 31. So this would be vertex P. P, must be vertex Q. The side that corresponds to the acute angle is shorter than the other side. So we start thinking about that short, acute ass again. We have to calculate the height. The height is going to be 31 times the sine of 29, which gives us 15.029. This height here is 15. It would be possible to lean a 23-foot ladder against a 15-foot wall. That does work. And unfortunately, that would also work if you put the 29 here. So this is R. If this side here is 31, this would be vertex P, this would be vertex Q, and this length here is still 23. Okay, you can either put the 23 facing this way or this way. That's why we get these two solutions. If you want some more practice on these, I will make another whole presentation that goes over them, but you've got some practice in your homework, but there's lots of situations that I haven't covered here. So I'll pause this video for now. If you want to see another video on this, then I'll make another video for you about that.